Yeah, good evening all. Good evening all. I am audible.
Good evening, sir. Yes, yes.
Okay, thank you.
We can hear you.
Thank you for the confirmation. Yes. So this is the week 3 discussion class for design of photovoltaic system. This course is being taken by Professor L. Umanan from Department of Electronic System Engineering from IIT Bangalore. And I am Ravi Kumar, a PMRF research scholar at IIT Bombay. So before this, we have seen the basics of photovoltaics, like what is this solar cell is, how it works, and what are the series and parallel connections for the photovoltaic systems. Now we are moving this third week. So first of all, we have seen the efficiency measurement of a solar cell, and that is efficiency equals to P out divided by P in. P out is output power from the solar cell. So wait a minute. Hello. हाँ यस, क्लास में हूँ, बताओ. ओके, मैं इसमें तो ढोकला था. ठीक है. Yeah, I'm sorry for the disturbance. So yes, we were talking about this efficiency term. This P output is PMPP, that is the power at maximum power point. Even we can write it as fill factor into VOC into ISC. And second term here is P input, that is insolation in watt per meter square into area of cell or area of module. So this is the basic formula for efficiency. See, behind repeating this efficiency formula and term is the reason is that why we are going to study this week lecture. This week lecture depends on this solar geometry. So this part depends on what factors? This fill factor VOC, ISC are determined by PV technology. Means they are directly depending on the solar cell or solar module which we are using. But there is other term, that is insolation. This area is also depending on the solar cell and solar module. But insolation, how will you calculate this I? How will you calculate this I? And will it be same around the world? If no, then how can we get this? See, if you are going to install a PV system at your place, you need few informations like the efficiency, because based on this efficiency only you can calculate the area which is required on your terrace or on your place. So this is a basic term. We need to calculate it beforehand, and in this efficiency term we have a very important term, that is insolation, and which depends on what factors. How can we calculate this insolation, and will it differ if we go from one place to another? So these are the few questions which are being answered in this week. So how many of you have gone through this week lecture? Yes, no? If yes, you can write in the chat box as well. You are not seeing the lectures? One or two lecture? Ramesh Kumar said yes. Okay, great. So have you gone through the week 1 and week 2 lectures? Okay, I am getting responses. Ruchi, Saurav as well have done. Okay, great. So how did you find the lecture? It's easy to understand, and also assignments are based on the simple formulas. So why we are studying this, what is the motivation behind this, and how it is connected with this our design of photovoltaic system part. So that is the main understanding of this lecture. So this is about the efficiency measurement. It is a recap only. Then this efficiency depending on what factors? You write in the chat box, I'll write here. One by one, let me know what are the factors on which the efficiency of a solar cell depends. On what factors the efficiency of a solar cell depends? Yes, first term is itself insolation. It is in watt per meter square. So insolation, if you don't understand, it is the rays which are coming from the sun, and these are calculated like normal to the, if this is our PV panel and these are the sunlight, then this is the calculation of this insolation. It is a 90-degree angle. Okay, tilt angle, azimuth angle, yes, these insolations also depends on tilt angle, azimuth angle, direction, and Saurabh said area. Area is another factor, that is area. Yes. See, we have a PV module at our place, and I'm asking the efficiency of a PV panel depending on what factors. You are saying insolation and different factors of insolation. You are saying area. What about the PV cell technology? See, in this efficiency term, P output divided by P input we have. So P input is depending on these factors. But P output is also dependent on some factors, which are solar cell technology. But let's say we have only one technology, let's say crystalline silicon. And if we have a crystalline silicon at one place, will the efficiency will be the same at every place? Will the output will be same at every place? So these are the basic questions which we need to answer before designing any photovoltaic system. Yes, third is the technology. Okay. And what do you understand by the term this insulation? What is this insulation is? Okay, see, I'll just tell you in brief. Let us assume we have a ball here, and you are standing at this place, let's say, and we have a torch. Light is coming like this. If I am having this area A, and this light which is coming on the surface of this A, let's say this way, and if I am moving this torch like this from here to here, so tell me, does the movement of this torch affecting the light which is coming on the surface A? Will it vary with the motion of this light source? Yes or no? Yes. Yes. So this is one factor here. Also, if this ball is moving in this direction or it is rotating like this, so this rotation, moment, tilt will also affect the light coming on this particular area A. Yes. And this A is very important to calculate the efficiency, very important to design a photovoltaic system, and that's why we are here to understand the solar geometry and other parameters by which we can calculate the insolation on a normal plane at any position or at any place on the earth. So that is the basic understanding. Okay. See, sunlight is coming from the sun, and do you understand, like, sunlight is a spectrum. Spectrum means light having many components. Components means different wavelength. And the sunlight is having different wavelengths. That's why we have a spectral irradiance, or we can say spectrum of solar radiation. And this is the spectrum of solar radiation here. So in this figure you can see these are the different wavelengths. I hope you understand the wavelength and all. It is a property of light. So like any light source which have any light coming from this will be having light at different wavelengths. And this is the irradiance, means it is a power. We can say at light of particular wavelength will be having some power, that is in watt per meter square. Per meter square, because we cannot calculate the entire area, that's why we take it into per meter square. And per nanometer means we are looking into the power of any light of any particular wavelength. So there are three basic or like main important terms here. This is UV, visible, and infrared. UV is ultraviolet, then visible, and then infrared. Wavelength increases in this order. So it means the light which is coming from the surface of a solar cell is having many components of light. It means it is having a spectrum. A spectrum means the total energy which is coming on the surface of a solar cell is spread over at different wavelengths. Okay, one basic question. Which light do we use in solar cell? Which part of this spectrum we use in solar cell? Is it UV, visible, or infrared? Visible. Shalini said visible. Okay. Visible. Ramesh also said visible. Okay, you are right. We are having only visible light source which is being utilized in a solar cell. But like, do you wonder why can't we use the entire spectrum? Why can't we use the entire spectrum? Why we are utilizing only the smallest or like small part of the spectrum only? If possible, can we utilize a broad range of spectrum? And if we will do so, then the efficiency of solar cell will increase. But do you think why we are not utilizing the UV or infrared region? What is the factor which is limiting the usage of this spectrum? What is a solar cell then? Just think about the basics of solar cell. What is this solar cell is and how it converts light energy into electricity. You will get your answer there. Nobody knows. But have you thought about this before? This question arises in your mind at any point. If we are having so much irradiance coming on the surface, then why we are not utilizing the entire spectrum? And that is the reason why the efficiency of the solar cell is only 17 to 20%. No. Okay. Search on the internet, you will get it, but I just want to tell you it is because of the limitation of band gap of semiconductor material. Because you have seen, like, if this is a band gap Eg, and these are the particles which are coming to the top surface, and this is a light coming, so the energy of this light should be equals to or greater than Eg, right? Right? And if energy is less than this Eg, then that light will be wasted. So it is the basic thing. Okay, so from this irradiance, how we come to the word that is the insolation? See, this is the energy in terms of watt per meter square per nanometer. Can we integrate it for all the wavelength 0 to infinite lambda? If we will do so, we will get the insolation, and that is the accumulated effect of all the wavelengths. So it is like integration of this energy with all the wavelengths, and that is in kilowatt per meter square. So it is all about the energy. We were having a solar spectrum, that is the light coming from the solar cell, so that is light coming from the sun, and this light we are converting it into irradiance to the insolation, because insolation will be used to calculate the efficiency. Because for a solar cell we don't need light of a particular wavelength, we see the entire wavelength. So this is the way by which we calculate the insolation. And like, because in efficiency term we have this L here, that is the insolation, and it is a light. Let's say if there is a sun, this is a solar cell and light coming on the surface of solar cell, so this light will be containing all the wavelengths. That's why we are integrating this for the entire wavelength. Okay, let's move next. At your place, how the insolation varies with time? Very basic question, and answer me. What is insolation? We can say in crude language, that is the sunlight. I am just asking how this sunlight varies with time. How it varies with time? Six a.m. to 6 p.m. Yes, it is. We can say it is the entire length of the day. But the sunlight will be the constant from 6 a.m. to 6 p.m. No. That's why I'm asking insolation variation. See, understand the terms. Insolation is watt per meter square. Variation means changing with time. Does this watt per meter square quantity changes with time? Yes, because you are right. Everyone is saying changes, but how it changes? It is asking this watt per meter square variation. It increases, decreases when it is maximized. What is the insolation at sunrise? Just before the sunrise? Almost zero. What is the insolation just after the sunset? Almost zero. and at what condition. See, this is, we can say, we have a term, it is sunrise, it is sunset, and this is like 0. So we are saying 0 here, 0 here. So will it be 0 for the entire day? No, it like goes up, become maximum, and then comes down. So this is the variation of insolation with time. This is our time. See, this is our sunrise, this is our sunset, and this is the variation this way. So it is in watt per meter square. Can we get in watt hour per meter square? What is this unit used for? Like watt hour per meter square. Is it power or energy? Energy. And this is watt per meter square. Power. So this is our power and this is our energy. If we just multiply with the time, it will become, see, power is equals to E by T. And if we multiply by time, then it will become our energy. So this is all about the insolation, how insolation varies with time. Now we understood one term, that our insolation is depending on time. But are there any other factors as well on which this insolation will vary? That is the next thing. Factors affecting irradiance. What are the factors? What are the factors? Like, you might be from different places. Let's assume someone is from Delhi, someone is from Mumbai. Are they getting the same light at the same time? No. So what is the difference between the Delhi and Mumbai? You said they won't be getting the same, but why? Latitude and longitude, yes. So first thing is the geographic location. So it means our geographic location plays an important role in determining the irradiance. Okay. Second thing, at a particular location itself, if I am having solar PV module placed at different angle, will this affect the irradiance? The different placing angle of a solar PV panel will affect the efficiency, will affect the irradiance, yes or no? Yes, definitely it will affect. So second thing is the collector orientation. We say that tilt angle, how we are having or how we are facing our solar panel towards the sun. That is the second thing. Then, does the sunlight or like irradiance is same in the morning as compared to afternoon, or in the evening as compared to afternoon? Is it same? Yes or no? No. So we have time of the day. So time of the day is calculated using one angle, that is the hour angle. So it means time also affect this irradiance. Then If you are in Delhi, the solar irradiance at 12 noon in June and in December will be same. Time, place, everything is same, just I am changing the month. Solar radiation on, let's say, 1st June and 1st December in Delhi will be same or different? Sunlight you are facing, okay, different, yes. It means it is also depending on the time of the year, and this time of the year affect the declination angle, that is the delta. Okay, next comes to the other conditions. So like clouding and all, so we have atmospheric conditions as well which affect this solar irradiance. Direction, yes, direction means how we are collector orientation. So these are the factors which affect the irradiance, and here you need to understand which factor is having a particular variable. Every factor is having a particular variable, like geographic location having latitude, longitude, collector orientation having this beta, that is tilt angle, time of the day having is this hour angle, time of year is having this delta angle, atmospheric condition having this KT, that is clearance index. So if we get some formula which is having all these variables, then we can find out the true irradiance at a particular place to calculate the requirement of our PV system. So it means the location, the condition, the time also important in calculating the efficiency or requirement of a solar PV system. Okay, let's move next. But what is the reason behind this change? Okay, let me ask you other way. Why time of day and time of year is affecting irradiance? Tilt angle we understand because we are not putting it in the right place. Latitude we understand because we are at different position of the ball. But what about the time of the day and time of the year? What is this 1 year is? Okay, do you understand this thing? See. Okay, let me ask you one question. What is the reason behind the variation in weather conditions on the surface of Earth? You are right, Ramesh. You are saying due to season, but I am asking what is the cause of this season? Why there are seasons? Rotation of Earth around the Sun. Yes. See, this is our Sun and Earth system, and this is our Sun, and this Earth is rotating. See, if you will see here, this part is collecting light normal in this particular time. That's why in northern hemisphere it will be summer at this condition, because light is coming directly, while in other condition This northern hemisphere is here. Now the light which coming from the sun are not direct. And if these light are not direct, then it will be having less energy, and less energy will lead to the drop in temperature and will lead to winters. So this is the basic reason why we are having different seasons, because earth is tilted at a particular angle and this is rotated around the sun, and due to this rotation different parts are having direct sunlight on the surface of earth, and that's why we have differential heating, or we can say we have different seasons. Okay, this is the, we are seeing this system from outside, like from the earth, from outside the earth and from outside the sun. But if we see from the earth, then how it will be look like? It will be look like this way. Sometimes sun will be upside, then it will be like direct light, so it is summer. Sometime it will be downward, so direct will be in southern hemisphere, it means winter in northern hemisphere. And sometimes will be it at equinox positions, it means neither direct and nor indirect. We can say it is having direct lights on the equator only. So this is the condition of equinox. So this way the rotation and the tilt angle of this earth cause the different seasons and cause the variation in radiance. And we were talking about this year, time of the year, and time of the year we have a delta. How can we calculate this delta? This is the formula to calculate this delta. Write it down, this formula, because this formula we will be utilizing in calculating or in solving many numericals. Write it down. So this is the reason why the time of the year affect the amount of irradiance on the surface of solar cell as well as on the surface of earth.
Uh,
Yes.
Sir, sorry for interruption. I have one doubt. Actually, in summer season, the sun is very closer to the earth, and in that time, solar irradiation should be maximum. But as per pictures here, solar radiation is only 1.33 kilowatt per
Yes.
meter square, and in winter season, the irradiance is high.
Yes.
So my question is that in summer season the irradiance value should be high, but as per picture here irradiance value is low.
Yeah, irradiance means we are talking about per second conditions. Let's say Ladakh. We were talking about Ladakh once. So in Ladakh, what happens? Irradiance is high, but conditions are like winter.
In what condition?
In Ladakh, the temperature is more or high? What is the temperature
High.
in Ladakh?
High.
High or low?
Ladakh.
It's winter-like condition or summer-like condition in Ladakh?
Uh,
It's winter-like condition. Ladakh is the cold desert. See, your questions is like valid, because this is the main confusion which comes to everyone's mind, because it is far and it is the short distance. But if you will calculate the effect of this distance and the effect of the direct radiation. So the effect of direct radiation is much more high as compared to this distance. See, these are the terms which is not calculated by me. These are from the lectures only. But understand one thing only. See, this is the direct radiation and this is indirect radiation. So in case of a direct radiation, the effect of this direct radiation is much more as compared to the effect of this distance. Distance effect is minimal, while you see the effect of direct and indirect radiation, or we can say direct beam, and it is not diffuse, it is like coming at particular angle. Sir, yes sir, in diagram I think 21 December should be replaced by each other. No, see, these calculations might be wrong, but this is absolutely right. This is absolutely right.
Because sir, we see in summer season, if there is generation is high
Oh, so sorry.
with respect to
See,
winter season.
everything is correct here. Let me tell you. See, here this 1.41 kilowatt per meter square is a value which is in the calculated in the southern hemisphere, not the northern hemisphere. And this is the condition when there will be summer in southern hemisphere, that is the Australia. So in Australia usually we have summer in December, and in this condition the upper hemisphere, or we can say northern hemisphere, will be having direct radiation. That's why these are the direct radiation calculation. These are not, these are at different hemisphere. It means this 1.33 is calculated at the direct heat, and that direct heat is at northern hemisphere in this case, and this 1.41 is here in the southern hemisphere, because these conditions are not calculated at the same place. So this time and these values both are correct. If you not understood, I can tell you once again. See, light is coming on the surface of earth. So this is all about the light only. This is not about the which hemisphere or which part of the earth. So it is the calculation of direct radiation coming on the surface of earth. So in this case, if you see, this is coming in the southern hemisphere. It is coming on the northern hemisphere. We can say the summers in southern hemisphere are having more effect or more temperature as compared to summer in the northern hemisphere. See, I am here. If you are not understanding, let me know. I will tell you again and again.
Sir, actually, in summer season, the radiation comes direct beam.
Yes.
And in winter season, the radiation comes for reflected.
Not reflecting, but comes at particular angle.
Yes, comes in particular angle, not comes direct beam. So accordingly, the irradiance value should be, if direct coming, the irradiance value more, and if reflected irradiance, the irradiance values should be less.
Yes.
But just the scenario here, the just scenario is different, matlab opposite.
See, this 1.33 is calculated at this place. Let me see. See, I am just pointing 1 to 1 2, or like NS, northern, southern, northern, southern. Here it is all about northern point. It is all about southern point. See, here n value at n is 1.33. Here value of n, if you will calculate, it will be less than 1.33 definitely. But here it is calculated as southern point. That's why it is 1.41. If it will be calculated at northern hemisphere, it will be less than 1.33 definitely. Same case for the southern hemisphere. Like this is the direct radiation here, and here it is the indirect radiation. So here it will be less than 1.41. I'm just saying you one thing, the effect of this tilt is much more as compared to the effect of this distance. The impact of this distance is very minimal. There is all the values of irradiance which is like having different values. It is coming due to only one factor, that is the direct radiation and radiation at a particular angle. These both values are calculated at different points. That's why these are seeing like it is more and it is less. And that is true because it is calculated at southern hemisphere, it is calculated at the northern hemisphere. Okay, let's forget about this northern or southern. Just focus on one point. Just outside this surface here, this is a dot here and this is a dot here. So these values are calculated on this dot only. These are not on the same place which are calculated here and there. It is the direct radiation, not at a particular or not at the same place. See, I'll show you one more figure if possible, you can get it. See, this is just an internet search. Uh, See, is this visible to you? See, this is a sun rays coming on this northern hemisphere. You can see this sunlight will go there. So these are going at a particular angle and here it is coming directly. And it is the June 21st condition. And like from other picture as well. See, in summer, you can see this tilt. Upper is the northern hemisphere, below is the southern hemisphere. So it means due to this tilt, when there is direct radiation at this northern hemisphere, that will be a summer case. And when there will be like this direct beam is towards the southern hemisphere, it will be a winter in northern hemisphere. Are you getting it or not? Hmm. See, this distance, the impact of this distance is not much more. This see, it is 1.47, it is 1.52. So the different like impact of this distance as compared to the impact of this direct beam radiation is minimal. So don't think if Earth is closer to the sun, then it will be winter. Oh, sorry, it will be summer, and when it is far, will be winter. No, the main thing is there where which surface or which part of the earth is having direct radiation at particular point of time. That will be the summer and winter condition. You see, there are maybe many videos as well, like 1 minute. So don't go with this thinking like this distance is defining the summer and winter. No. The main reason of summer and winter is the direct radiation. See, also here also you can see. We are talking about a particular place. Let's say this place. And sun is here. So there are coming direct radiation there. And in this, if sun is there in the downward, so direct radiation will be there. Here it will be a particular angle. So this will cause the winter and this will cause the summer. The impact of distance is minimal as compared to the effect of this tilt. And if there is no tilt, there will be no season. Understand this. Understood or not? I'm trying my best to make you understood, and I'm saying everything written on this slide is correct, nothing wrong there. Saloni, have you understood this? In this picture, it is shown like this distance is much bigger as compared to this, but that is not the case. The distance, this and this, is not that much differ, or it does not differ that much, and that's why the impact of this distance is not much as compared to the impact of this tilt. Okay, you can go through like on the internet. Still, if you have any doubt, you can ask later as well in the next class, or in the YouTube comment as well, or in the like discussion forum as well. May I proceed further then? Just understand one thing, whatever written here is absolutely right. Because this value is not on the surface of earth, this is the outside the earth. These values are not on the surface of earth, these are the outside the earth. I'm not getting any response. Yes, no. Am I audible?
Yes, sir, we can hear you, and your point is clear. We clear your Earth-centric viewpoint. It is more specifically to your answer, because if one body on the Earth, and there is changes of irradiation angle, that's why the value.
Yes, that is the main reason, and which
Yes,
this
right.
this is taken by this delta. Yes. Okay, so let's move further. Now we have like solar geometry. So in case of a solar geometry, we will see, so we have seen different angles, we have seen different factors on which this irradiance differ. Now we will understand from where these angles are coming. So this is comes from the solar geometry term, and this is the like picture from the lecture only. So you can see, first I told you delta. So delta is this. This is the, what is this delta? Declination angle. It depends on the time of the year. Then we have this omega. This is the hour angle. It depends on the time of the day. So two factors are there: time of the year, time of the day. Then we have this phi. This phi is latitude, right? And it means at which part or which geographic location we are, it takes care of that. And then we have this delta z, theta z, sorry, it is theta z. So this theta z is zenith angle. It tells us how much far is the sun as compared to the noon condition, or we can say as compared to our just above the surface. It is the zenith angle. Then we have this.
Sir, can you describe once about the zenith angle?
See, if you are standing at a particular place, and like this is one perpendicular line, and if you are seeing sun there, then the angle by the sunlight to this your particular like we can say normal, the angle between this normal and the particular sun condition will be the zenith angle. It means at noon, when sun is at your head, then the zenith angle will be 0. So it is just measurement of sun from the noon condition, we can say. Zenith means of the top. I'll tell you. See, if this is a surface and you are standing like this, so this is your top, and if you see sun at a particular place, let's say sun is here, and then sun is here, then this will be the angle between, this is sun is here and you are standing here, so the angle between these two will be our zenith angle. So how much sun moves as compared to the noon condition is the zenith angle. Then we have azimuth angle. So this azimuth angle, nothing, just the, I am saying sun, take the sun in the your normal plane, and the angle between this normal condition or reflection of the sun in the plane with this south condition, or we can say south direction. So this is our azimuth angle, and all the angles are written here. We have geographic location, latitude, longitude, then tilt, then time of the day, hour angle. Tilt angle is not here because we are not having any surface as of now. Then we have time of the year, that is our this delta. Then we have theta z, zenith, and then we have gamma s, that is azimuth. So these are the different angles we have in solar geometry. Then based on these angles, we calculate insolation on an horizontal plane. Now there are two things in case of insolation. One is that we can have this insolation, that is watt per meter square, and also then we can have insolation watt per meter square per day. So for both the things we already have two formulas like this. This is the formula for insolation on an horizontal flat plate placed at a locality on latitude phi. It means at any place if you are having a flat plate, then insolation of that flat plate can be calculated using this formula. And here we have this delta phi gamma. So these are angles which we understood, and this L is the extraterrestrial insolation which was calculated in that picture, that is 1.33, 1.42, which were we discussing about. So this is the that L. Then we have daily energy. It means we are taking an integration over the hour angle. We can say the entire day, and this is the formula for this entire day thing. So this is the energy. See, if this insolation is being integrated with the hour angle like for the entire day, then we will get this. So using these two formulas, we can calculate insolation as well as irradiance, or we can say the power as well as the energy. And this is just an algorithm way. So we just put this latitude, we just put this n number, and using this three different quantity, we calculate this h naught, that is a daily energy incident on the surface of a flat plate. So now let's solve some problems based on all these. I think yes, very simple question. On which day of a non-leap year does the maximum insolation level occur for an angle of 18 degree formed between insolation line and equatorial plane of the earth-centric coordinate system? There are two things here. First, you need to identify which angle is this, and then you need to identify what is the meaning of this non-leap year. These are the options. Just try to solve it. If you are not able to solve it, then let me know. Between the insolation and equatorial plane of the earth, which angle is may be? Are you solving it? Yes or no? Okay, I'll tell you one thing. I'll draw for you. If this is our earth, so this is the earth centric equatorial plane. We can draw a line as well. And let's say this is the sun, and this is our insolation line. This is our insolation line, this is equatorial plane, and this is the angle. And this angle is maybe, I told you, like I have shown you the different position of sun, and this angle may be like this as well. So what angle is this? See, this position of sun moves up and down daily, monthly, or yearly. Sun move in this direction daily, yearly, monthly. What is the time frame? You can write in chat box if you don't want to speak.
Declaration angle.
Yes, that is a declination angle, right? So you have a formula for the declination angle. Put it in the formula, everything, you will get the value. Do I need to give you the formula? I request you to be more interactive. Solve the queries, solve the questions. Then only we can learn here. And we are here not to just solve the problems or just see the solutions. We are here to try. So try this question. If you are not know the if you don't know the formula, let me know. I'll give you the formula. I'll tell you the step. Just try. If you are not even trying, then I don't think there will be some benefit of these lectures. This is the like formula which we will be using in this question. So delta is given and we need to calculate this n, and based on this n we need to calculate the date. Now at least try. Today's people are not trying. Prabhakaran, Ruchi, and at least try this question. Okay, Salini said 11th May. So Salini, what is your n? Ruchi also said 11th May. What is the value of this n? 131. Okay. And this non-leap year means you need to take Feb at 28. Yes, 11th May is the answer. Next question we have, if an angle formed between the zenith axis of a local coordinate system, it means wherever you are standing, the zenith angle at your place or zenith axis. Zenith axis means the line which is going through, like the perpendicular line. And the median axis of the earth coordinate system is 35. Then how many hours are there in the longest and shortest day of non-leap year respectively? So here you just, yes, you are absolutely right. It is 130.86. So we can take it 131. Yes. So in case of a non-leap year, you need to calculate the longest and the shortest day. And these are the options. Okay, we will go step by step. What is this 35 degree is? What is this 35 degree is? See, if this is the earth, and I can say this is a plane, and this is the zenith axis, and it is saying median axis of the earth coordinate system. Median axis will be like this here only. So this angle is what? Prabhakaran said B means 12.35 and 8.64. Okay. So 35 is what? What is this phi angle is? what is this phi angle is? It is latitude. So phi is the latitude. So it means this 35 is the latitude of the location on the earth. So first thing is clear. We have identified which angle is given. Then you need to calculate how many hours are there in the longest and the shortest day of the non-leap year respectively. So you need to calculate this omega, that is the hour angle. And using this hour angle, we have a direct formula for the time of the day. Should I give it to you, or are you calculating? Are you doing it? Okay, this is the formula in front of you. So T will be the cos inverse tan delta tan phi. And question said longest and shortest day of non-leap year. So first of all, you need to identify which all formulas we are using here. So here we just need delta and phi. Phi is given 35. What we require? Delta. How can we get the delta? Okay, when is the longest day at your place? Longest day. Is it in Jan, Feb, May? When it is there? Summer, winter?
21st June.
Okay. And when is the shortest day?
21st July, December.
December. Yes, Salini. So it means we are saying that there are two conditions. One is summer solstice and another is winter solstice. And what is this delta at summer solstice and winter solstice? It will be maximum. So it will be like this. If we are having Earth, Sun here, this is our equatorial plane. So it will be like 23.5 positive, 23.5 negative. So longest, shortest. So you just need to put delta as positive 23.5 degree, negative 23.5 degree, and put phi 35 and calculate this T. Now at least calculate. I will also calculate. Calculate, guys, please. D. Charlie said D. Soro said 552.8. What does this mean? 552.8. This is the hour of a day. Yes, Soro, hour can be only maximum 24 hours. Ruchi said D. And Prabhakaran said B. B for this question or the like previous one? I don't understood. Okay. So we got two answers. D. Okay. Yes, D is the correct answer here. So we have to take like exact value as these things, but we can use 23.5 and D is the correct answer. You just need to put in this formula and calculate it. Let's move to the next question, which says calculate an equivalent standard insolation times in hours considering the standard insolation as 1 watt per meter square from the insolation graph given in the figure below. These are the options. It means we need to calculate the hour. See, we need to convert this into this picture like this. And this is the x which we need to calculate. This is the current situation. Irradiance, it is increasing and decreasing. But we want equivalent in standard insolation time. See, same standard insolation when we have only 1 kilowatt per meter square. Yeah. So you need to calculate this x. How will you go for it? Very simple problem. I don't know what is the issue you are getting here. What should be remain between these two pictures? What should be the same? It should be the area. The area under this curve and area under this curve should same. Now at least calculate. Okay, Mayur said 8.52. Okay. Ruchi said area, absolutely right. So what is the area here? Okay, it's okay. 1.2 into 12 into 1.42. And area here will be x times only x because here we have only 1. So divide by 1, it will be 6 into 1.42, that is 8.52. So 8.52, correct answer is B. Now, next question says, consider the things from question 3 and calculate the number of solar panels need to satisfy a peak load of 20 kilowatt hour if each solar panel has a rating of 100 watt. Then how many solar panels we will need, and these are the options. 20 kilowatt hour load is there, and you need to calculate the number of solar panels you need. Very simple problem. See, we have given the energy, convert it into power, and we have power of one module. Using these, calculate the number of modules required. Ramesh said A. What is the energy given? 20 kilowatt hour. How can you convert it into power? Power is, what is power? Energy divided by time. So 20 kilowatt hour divided by x hour, and x take from the previous question, divide it, then we have power of one module is 100 watt. Match the power and find out this N. So simple. Let me know the answer. What is this X? How many hours we got in the previous question? Because
area.
Here no, X is not the area. X is the in R. We calculated in the previous question itself. Because Mishra said C, 24, okay. X was 8.52 R, and divided 20 kilowatt hour divided by 8.52, then further divide by 100, you will get N. Mayur said 24. Yes, 24 is the right answer. It will come around 23.85 something, but you should have 20. Yes, 24 is the right answer here. Next question says, what is an angle in degree formed by insolation line and equatorial plane? So which angle they are talking about? Ramesh also right, 24. Which angle they are talking about? Insolation line, equatorial plane. Which angle is correspond to the time of the year? It is it is delta, declination angle, and these are the options. Calculate this. Use the same formula. Yes, Mayur, you are right. Declination angle is the being asked in this question. Yes, Vikas, right. Declination angle is being asked. Do you need formula? If you need formula, let me know. Okay. This is the formula. Use this formula. Calculate this delta. Sorry. Yes, delta. What is n corresponding to this date? Put this n here and calculate this. Salmi said A, 0.5. Okay. Let me know if you are facing any issue, any error in your answer. Three 3.77. Sanli said 0.5, you said minus 0.377. Ruchi said, so we are having 2 votes for A and 1 vote for 3.77. We can go to B. Okay. What is N? How much N is? What is the value of N you are getting? I have taken N 272. Ruchi taken 275. Why you have taken 272? It is like January, February, March, April, May, June, July, August, September, October. Two 75 minus 0.5081. Okay. Okay, so we will go to the answer. Then answer is A. 0.5 is the correct answer. Yeah, minus 0.49, then it's 5. Yes, right. Next question. is about calculate the maximum insolation level in kilowatt per meter square for a latitude angle between the zenith axis and the local coordinate system, and median axis of the earth coordinate system is -20 and declination angle is 10 degree. These are the options. You need to calculate the maximum insolation that can fall on the surface of a solar cell, surface of a plane, and this surface of a plane, local coordinate system, zenith angle is given -20. Identify this angle, this is our delta, this is our phi, and calculate the maximum insolation. If you need any formula here, let me know. Maximum insolation, which I have shown you two formulas, one for the maximum energy per day, one for the maximum insolation. So the maximum insolation one formula will be used here. You need the formula, let me know. You don't need the formula, give me the answer. I have told you this is our phi and this is our delta. If you are not solving it and need the formula, let me know. You need to calculate the maximum insolation level for a latitude angle which is already given, and declination angle is already given. So first calculate omega, and using this omega calculate this insolation. Formula, yes. Formula. The value of this is 1.367 kilowatt per meter square. First calculate this omega, then then use this to calculate Lx, and Lx is the value of your maximum insolation. Okay, I'm also trying. So it is saying 10.5. What is the hour angle? Depends on what condition? Hour angle depends. Is it 93.67? No. What is this 93 means? It's in kilowatt per meter square. (93.67 degree) hour angle. Is it hour angle? See, you need to understand the basic thing. We are here, sun is here, it goes like this. And our angle at noon is 0. It goes positive 90 to negative 90 to positive 90. And here it is asking maximum insolation. And maximum insolation will be at what condition? Noon condition. Yes. I hope you understood. If omega will be 0, this term will be 1. Now what left? Lz equals to L sine theta sine phi cosine delta sine phi plus cos delta cos phi. You need to solve it. And also we can write it like this. L, this is the formula of cos A plus just solve it, like put values here, 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 here and solve it. B 1.2. Yes. So this is a formula, nothing like cos delta minus phi. You can put here as well values and then you can calculate it. Ruchi said B 1.2. See, I just want to tell you one thing. Even in this question, you don't need to calculate anything. Just by seeing the option, you can write the correct answer. See, the extraterritorial insolation itself is 1.367. So, on the surface of Earth at particular condition, the insolation can be more than this anytime. No, the insolation cannot be more than this in any situation. And every value, every option is more than this. Only 1.2 is less than this. So this value which is less than this will be the answer. But with this all values, I am getting final answer 0. See, here understand the question. Even you don't need to calculate R angle. It is saying calculate the maximum insolation level in kilowatt per meter square. It is saying maximum insolation. When will be the maximum insolation? When will be the maximum insolation? If you are at your home, when will be the maximum sunlight falling on your head? When it will be? At what time you will be receiving maximum irradiance, maximum sunlight at your place?
Declination angle is 0.
Declination angle is not 0. Declination angle is 10.
Not that time, because midday we get the maximum.
No. See, it is not saying that at any point of the year. It is not saying any point of the year. It is saying when the declination angle is 10. at that point of time. So by giving this angle, it have defined the day. So day is already given. So by just giving this like delta, they are giving us the day. So particular day, in this particular day, when we will be having the maximum insolation. Insolation varies with time in a day, right? So the omega, that is the hour angle, that takes the like effect of this variation in a day with the time, and this hour changes like this from sunrise to sunset, and at particular point of time when the sun will be at your head, that will be the condition which usually say noon condition, and at this particular condition you will be receiving the maximum insolation. So by this giving condition, omega is 0, and by putting this omega 0, cos omega will be 1. Then you will use this formula, you will put the values and you will get the answer. Any confusion? It is not saying maximum insolation in a year or across a year. It is saying at a particular condition, at a particular site, when the phi and delta is given. So 1.2 will be the answer here. Okay, next question is simple. It is saying what is the zenith angle formed between the zenith axis of the local coordinate system and the insolation line of the insolation level calculated in question 6. So these are the options. It means if you, this is the earth and this is the plane, this is our zenith angle, zenith axis, and let's say sun is here, this is our zenith angle theta z, and this is our, we can say, insolation line here at this particular place, and on the surface of earth it will be this insolation line, zenith axis of the local coordinate system and the insolation line of the whole system. So it is asking about this theta z. Theta z will be if you will do the geometry, you will get this theta z is the difference between this phi minus delta. This is a common relation between this phi and delta. And what is this phi is?
Latitude.
Okay, how much phi is given?
Minus 20.
Minus 20 minus 10. How much it will be?
Minus 30.
Minus 30. So in this case, we can say minus is the just direction only. So we can say 30 is the answer. Let me check. Yes. It is the 30 degree. So it is a like common relationship between this phi z. Even from the question like which we just did it, L equals to Lz cos theta z. We also can do this like this as well. And this theta z is phi minus delta. Okay. Next question is, Calculate the effective insolation in the local centric coordinate system on the horizontal plate for a zenith angle 40 degrees on 20th March. And these are the options. It is saying effective insolation you need to calculate. Flat plate for the zenith angle is given and you have given the particular day. Here also, which I told you, you can use the simple formula L equals to LZ cos theta Z. Try it if you can do it. Let me try. If using this simple formula we can obtain, or either we need to do with this complete numerical or complete formula which we have. It is saying 40 degree. So cos 40 into what is the answer? Zenith angle is given 40 degree. This is LZ. LZ equals to 1.367 into cos 40. How much? How much? Just do it. Cos 40 into 1.367.
0.91.
How you are getting 0.91? B, yes, Ruchi B. You might be solving it like you are taking radian or degree. You are not using the correct way. So just put. Why you are getting 0.99? I am not understanding. Let me do it radian. Let's say if there is problem with this. Yes, 0.911 is coming when you are taking this cos 40 in radian. It means you need to calculate it in degree, not in radian. Convert your calculator into degree and then do it. Yes, Vikas, 1.05. 1.05 is the answer. And like in the long way, you can use the same formula and you can have different values using all these values. So answer here is B. Next question. It is the easiest question. It says compute the solar irradiance in kilowatt per meter square for the graphs on in figure, where this I is the wavelength and this is the power density, and these are the options. So what you will do here? Just tell me. How will you solve this question? It is the power density. It is in kilowatt per meter square per nanometer. It is in nanometer. If you will multiply in nanometer, you will get kilowatt per meter square. It means you need to take the area of entire figure. And how will you calculate the area? Just compute this area, this area, this area, and this area. So it will be 1 by 2 into 1.25 into 440 plus difference will be 500 into 1.25 plus 1.2 into it will be 1.25 and 45 into 3550 plus 1.2 into 500 into 1. Just add, do this. Will we not convert the area under the curve in the visible? No, actually we are not saying here in the visible light zone only, because we are not saying the part only which will be converted into electricity. Here we are talking about the entire insolation coming on the surface of any surface. We are not talking about the solar cell particularly here. How much you are getting? You just need to multiply and add. Three one one eight and convert it into kilowatt. Is it in watt or kilowatt? You are not doing, and let me do.
अरे भाई 10 225 so 6 7 5
Yes, there is a issue with this key. It is in watt per meter square. Formula, there is nothing formula. It is just need to calculate the area under the curve. just compute the area under the curve. And Ramesh, you have like you forget to take this term. You have calculated only till here.
Yes, sir. After that, final answer is 3.3.
Yes, it is 3.3. Answer here is 3.3. You just need to take the area under the curve. Okay, let's move to the next question, which says compute the amount of daily energy, it is kilowatt hour per meter square, available with the declination angle that is 45 on the equator line. See, it is saying on the equator line for the day that is the 5th September 2023, and these are the options. So on the equator line, what will be the phi? What is the latitude of equator? Zero, yes. So this is the formula which you need to use here, and you will take phi 0, so sine 0 will be 0, and so this complete term will be gone, and here you just need to take this, and if you will take this, you will put cos phi is 1, cos delta, and sine phi, sine omega you will calculate from here, and using this you will put omega there, and delta already given 45, and like k you can calculate using this, and you can calculate from this date, and what left, this LSC is given 1.367. So using this you will calculate the total energy. So how much it is coming? You do so, everything is here, n is here, using n calculate k, then we have this, okay, so tan phi will be, if phi is 0, tan phi will be 0, so it is 0, and cos 0, it means 90, so our omega is 90. If you will here omega 90, it will be 1, so sine will be 1, so it will be cos delta only. So your formula will be h naught equals to 2/4 divided by pi into k into LSC into cos 45. Just you need to do it, cos 45. LSC is already given 1.367. K, how much K you are getting? It is 5th September. January, February, March, January, N is 248. N is 248 into 360 divided by 365, 244.6 cos 244.6.9 into 0.033 plus 1. So K will be 1.029, and other things are given. So it's like 1.029 into 1.367 into cos 45 into 24 divided by, it is coming around 7.3. So answer here will be 7.3. Just solid calculate it, you will get it. K will be around this, N will be around this. Put it there, calculate it, you will get 7.3 kilowatt hour per meter square. Any doubt here?
Sir, phi is equal to 0. I'm not understanding.
Phi equals to 0, it means we are talking about the equator. See, this is the equator, and if we go up, this is our phi. Phi means latitude, and even itself we are talking about this point. So latitude of this equator will be 0.
Okay, got it.
Yes.
And what condition omega will be 0, sir?
Omega will be 0 in the noon only.
Okay.
So answer here will be C. So we are done with today's lecture. I'll upload this lecture in the YouTube, and we will meet in the next class. Question number 1 and 9 show me. Okay. Question number 9, this one. Thank you everyone. So this is the channel on which I'll upload these lectures. So be more interactive, solve questions, ask queries if you have. So like Prabhakaran, you have seen the question 9. I'll show you question 1 then. This. See, this is the question 1. Just putting the formula, putting the value of n, you will get the answer. Okay. Okay, then take care. We will meet in the next class. Thank you.